Okay, so next we want to look at the example. If we have to solve the area to get the area and volume in polar, using polar coordinate system. So in this case, we are given a region that lies inside the circle with circle 2 sine theta. So on the previous example, we have sketched 2 sine theta. So we have the circle shifted where the center now is at 0, 0, 1. And the circle with radius 1. So the region is inside the 2 sine theta but outside the circle. So then the region should be lying over here. Okay, outside the circle with radius 1 but inside the 2 sine theta. Okay, so it looks like you need to obtain the because you have to determine the limit of theta and the limit of theta. So you have to know the line of this. So we know that how can we get this line when your theta is constant. So to obtain that value, what you have to do is find the intersection point of the two curves were given by r equal to 2 sine theta and r equal to 1. So when we solve that, so you will get 2 sine theta is equal to 1. Sine theta is 1 over 2. So theta is inverse sine. Inverse sine 1 over 2. Okay. So if you have to use the calculator to evaluate this. If you set in the radian, so the answer is pi over 6. But if you set in degree, so the answer is 30 degree. Okay, so here I'm using the radian. So pi over 6 is 30 should be on the first quadrant. So now we know that this line belongs to theta equal to pi over 6. And because of the size of this angle should be the same. So this is also will give you pi over 6. But then the way you evaluate the angle, you compute the angle is starting from x-axis is positive. So the first theta is pi over 6 and the other theta, how can you get that? So you have to subtract pi is 180 minus subtract the pi and pi over 6, and this will give you 5 pi over 6. So the theta that we have is pi over 6 and 5 pi over 6. So this is this line. So this one is belongs to theta equal to 5 pi over 6. Okay. So that is about the theta. Okay. So now we want to find the area using double integral. So 1 dA over the region lying on y-axis plane. So we use polar. So we have r dr d theta. Okay. So the limit of theta, we can look this. Obviously, the theta is from pi over 6 to, so from the diagram here, so the theta is, the region is lying between the theta equal to pi over 6 to 5 pi over 6. Okay. And then how about the r? So the r, how can we determine the r? You have to provide the line. So the line is starting at the origin. Okay. So now you can see that there is nothing, there is no region over here, but the starting point is at this and this, and you have to provide more lines, so they are all along the r equal to 1, right? And then when you keep increasing the r, so the largest r, the possible is lying along this curve, and this curve is given by r equal to 2 sine theta. Okay, so then we can substitute the value where theta is pi over 6 to 5 pi over 6, and then r from 1 to 2 sine theta. Okay, so now you have a complete double integral. So we can integrate. So first with respect to r, so you have 1 over 2r squared, r from 1 to 2 sine theta d theta. Then you will get 4 sine squared theta minus 1 d theta. Okay, so it looks like you have two terms here. So let's see, I separate them. So I will get 2 sine squared theta minus 1 over 2 d theta. So for the second term, you can integrate directly. You have to put the d theta here. Okay, but this one you need to reduce the power. You cannot directly integrate. Don't give me 2 sine cube theta over 3. So that is definitely wrong. Okay, if I told you before, if you have just theta squared, and you can directly get theta cube over 3 because just a single equation there. But if you have just a single layer of equation, but if now you have the two layers, so the outer is a square function, and but then the inner is sine, then you cannot use that way directly. Okay, then you have to reduce the power by using identity, trigonometric identity. Okay, so which identity that the most possible one, the most appropriate one? So the formula, don't worry, this formula is given during the exam, but then you have to know how to use them. Okay, so now you want to reduce the sine squared theta into just a power become 1. We don't want the power 2. So now where is the sine squared? So we have the sine squared here, right? So now what you have to do is by using that identity, so you have cos 2, now we use theta, cos 2 theta equal to 1 minus 2 sine squared theta, right? So then we can see that 2 sine squared theta is equal to 1 minus cos 2 theta. So now we replace 2 sine squared becomes 1 minus cos 2 theta. Okay, theta. And the second term, so you can get the answer directly. You have theta over 2. Okay, but we replace the limit later on. So we finish this first. So we have theta. Then now integrate cos. You have sine 2 theta over 2 minus theta over 2. Okay, but we need to simplify first. So you have theta over 2 minus sine 2 theta over 2. So the theta just now from pi over 6 to 5 pi over 6. Okay, since we can take out the half, so we solve for theta is 5 pi over 6 minus sine 10 pi over 6 minus pi over 6 minus sine 2 pi over 6. Okay, so 5 pi minus pi over 6 will give you 4 pi over 6. Then you will get 2 pi over 3. 2 pi over 3. Okay, and what is sine 10 pi over 6? And we need to evaluate that. Okay, so be careful when you evaluate. So you will get this value for sine 10 pi over 6, and then minus so positive, so sine pi over 3, we will get this, and when we simplify, and we will get 1.9132. Okay, so that is the area, so unit squared. Okay, the area of this particular region. Okay. Okay, so the next example, we have the area. We have to get, using polar, we have to find the area where it is enclosed by the 3 petal rows given by r equal to sine 3 theta. So now your equation is in terms of polar sine 3 theta. Okay, so if you don't remember, then you have to look at the polar graph, rose petal. So rose petal, so we have used the 2 sine theta. So now we have sine 3 theta, Okay. So which one? So this one, right? But your A here is which is 1, okay? So this is our the graph that we need to sketch. Okay, so if we sketch that, so we have this one, and this one, then sorry. Okay, and the size of the petals should be all the same. Okay, so now because we want to, okay, back to the instruction here, we have to evaluate the area of the 3 petal. We got 3 petal, 1, 2, 3, and the size of the petal, they are all the same, so meaning that it's enough for you to just compute 1 petal and just multiply by 3. Okay, so now let's focus on the petal in the okay, actually we have to compute all, but then just to make it easy, so we just compute the area on the first quadrant, and after you got that, and you just multiply by 3. So you should know the angle. So the angle, obviously, the theta that we should have. So the theta is, you have to find the theta of this, and you have to find the theta of this. So how can we get that? Okay, so since you are only given this one, okay, so the thing that you have to know is, as you can see from the graph here, we have not only r equal to sine 3 theta, but we can also have the r equal to 0, because we can say that the graph is passing through the origin. So to determine the theta that we have, then another r that we can have is not only r equal to sine 3 theta, but we have the r equal to 0. Yeah, r0 means the origin. As we know that, how can we have this? Why don't we use r equal to 1 or so on? But because of, you can see, all the petal here are passing through the origin, right? and meaning that the most possible R, another R that we can choose here for us to determine the theta, we can set the R equal to 0. So now we solve this simultaneously in order for us to determine the theta. So we can have sine 3 theta is equal to 0. So 3 theta inverse sine 0. Okay. So since we only interested on the first quadrant, so let's look at the graph of sine. Okay, so for the graph of sine, one cycle, so this one 2 pi, and this is pi, so this is 0. So now ask yourself, what sine? Okay, what sine? And the answer is 0. So from here, sine 0, you will get 0, right? So you have 0, one of the answer, isn't it? So sine 0, okay, sine 0, you will get sine 0, so 0 here, will get 0, and sine pi, so this one pi, you will get 0, and then sine 2 pi, you get 0. Okay, so now you have 3 theta 0, 3 theta pi, 3 theta 2 pi. So the first one, theta is 0 over 3, pi over 3, 2 pi over 3. Okay, so pi over 3 is still on the first quadrant, and 0 also on the first quadrant, but not 2 pi over 3, because 2 pi over 3 is 120 somewhere here. So this one excluded. So the most appropriate theta that we have here is 0 and pi over 3. So meaning that I should redraw this one. So so this one, the angle, so theta 0, and this one theta pi over 3, or 60 degree. Okay, so then because of we want to evaluate the area, so we considered only one petal over here. Okay, but then because of we know the size of the petal, they are the same, then we should multiply by 3. So I just put directly 3. Okay, and then 1 dA over the R on xy plane. Okay, so now we want to solve using polar r d theta. So the limit of theta we already obtained, so theta from 0 to pi over 3. How about the r? Okay, so now to determine the limit of r, so we have to draw a line starting at the origin. So you can put many lines because we only focus on the first quadrant, so we just look at here. So as you can see that the r that you have starting, they are all starting from r equal to 0 and end up on this line, or on this curve. So okay, so the curve is sine 3 theta, belongs to the sine 3 theta. Okay, so now we already obtained the limit of r and theta, then we substitute here. Okay, so now we start to integrate. So firstly, we have to integrate r, then we will get r squared over 2, and replace r0 to r sine 3 theta. And when you substitute, so you will get 3 over 2 sine 3 theta square. Okay, so in this case, you cannot directly integrate with respect to theta because you have multi-layers of function here. So meaning that you have to reduce the power into 1. So in order to reduce this, you have to use again the trigonometric identity, where in general, So this is from the identity of trigonometry. So as we know that the sine square A is given by 1 minus cos 2A over 2, but now your A here is 3 theta. Okay, so because this is what, this one I'm consider this one A, so A is 3 theta. Okay, and then when we substitute this, so we have 1 minus cos 2 3 theta over 2. Okay, when we expand that, so we got 3 over 4, 1 minus cos 6 theta. Okay, then we can integrate. So 1 will get theta, integrate cos, you have sine 6 theta over 6, and then you substitute the theta equal to pi over 3. So 6 pi over 3 will give you sine 2 pi. So sine 2 pi, we know it is 0. Okay, and then we just have, we can cancel out 3, then the answer is pi over 4. Okay, so that is the total area of the 3 petals here. Okay,